Hello again. Today's video is about link aggregation or Ether channel. It's about combining multiple links across switches, and you can put it into servers and routers as well, but we're just going to use switches so that we can get more throughput from our switches. Now the question is, why do we need that? So let's have a look at our little switch network in here. So we'll zoom in a bit. It's pretty good. What we have is a switch down the bottom left here, so let's have a look at that. And physically, let's zoom out. Oh, we should zoom in, shouldn't we? We've got 24 fast Ethernet ports, and 2 gigabit ports. Now, if we've got 24 fast Ethernet ports, if we want to give everybody the same speed at 100 megabits per second, then that will equate to 2.4 gigabits per second coming out of the switch. Now we have 2 gigabit ports, so 2 gig, 2.4 gig, it's pretty close. So if we have both of these gigabit ports connected, then we can get close to full line speed for this switch. And most switches are designed that way. If you get a 48 port switch, it'll have 4 uplinks on the side there. Now there is a problem with that. That is, if I plug in another cable, now I've got fast Ethernet 4 in there, and I'll fast forward time. Now I've done some bit of background here. I made fast Ethernet 4 a trunk, and I put the trunk onto the correct native VLAN as well. So if you don't know how to do that, pop back and have a look. So I've done a bit of pre-dunning. Now all I've done there is said I've got 2 links going from this switch down the bottom left to the switch at the top, and one of them through spanning tree is in blocking mode. So if we just pop into that one and have a look at this, and we'll show our spanning tree. Then port 4 there is in blocking mode. It's an alternate port, and that's because spanning tree loop is happening just across this little area there. So what do? We can combine these 2 links as one link, and that is called link aggregation or Ether channel. And that's what we're going to do. Now first of all, we need to actually cable everything up correctly. So if I don't make mistakes here, it'll be a lucky thing. So let's try and work slowly, and when you do yours, be very careful as to where you're plugging things in. So first up, I want ports 1 and 2 on this switch to connect to ports 1 and 2 down here, and then I want 3 and 4 on the top switch to connect to 3 and 4 down here, and then 3 and 4 on this left switch to connect to 1 and 2 on the right switch. So let's see if I can get this going properly. Now first up, I'm going to take that port off 3. It was on 3, and I'll put it on 5 because that's my router on a stick connection, and I need port 4 for something on this side here. That one I'm going to connect to 3, and down here it's going to be 3. I'll grab another cable here, and I still have a 4 over there, so let me escape out of that. Let me just move this one over to there. So that was 4 and 4 now, even though we can't see it popping up, which is a bit annoying. We'll just quickly show in preferences. It's going to get messy, but let's just do it. So there's 3 and 4 of those 2. 1 is that one, 5 is the top one. 3 and 4, the 2 hiding behind there, and that's all good so far. So let's just clean that up, and let's do the other side of the top switch. So 1 is going to connect to 1, and up the top here 2 is going to connect to, needs to be 2, so let me hop out of that one. Just move this one down a bit. So get my cable back. So 2 connects to 2. So let's just double check as we go through. Just make sure, follow my cable through, 1 and 2, connect to 1 and 2 down there. So that's good. Should probably do the control out, it's a bit quicker, eh? Okay, so 1 and 2 at the top switch connects to 1 and 2 on the bottom, and 3 and 4 at the top switch connects to 3 and 4 on the bottom right. We don't have to put an ether channel across here, but what I'm going to do is show the 3 different types of ether channel. So we'll put a third one in. The reason I say we don't have to is if this is the root bridge and we've only got 3 switches, then you might as well use this channel group from switch 1 at the bottom up to switch 2, say, up the top, and 3 up there. So if that's the root bridge for all your VLANs, then this could just be a bit of backup, a bit of redundancy. Okay, so let's pop down the bottom here. So 3, 2, 1 on this side. Don't forget that. And from there, you're going to go to 4 to 2 on the right hand side. Now spanning tree should kick in and everything should be a bit messy for a while, but let's pop in and do our ether channel. Now the 3 versions of ether channel we're playing with that are available on Cisco switches, at least in Packet Tracer, are PAGP, or Port Aggregation Protocol, LACP, which is Link Aggregation Protocol, and ON, it's just ON. Now PAGP and LACP do negotiate, so we'll talk about that as we go through. Let's pop on the top switch and we'll configure this connection up here and work our way through that. Now we should have native VLAN mismatches all over the shop actually. Because we're rebuilding something, it does or will get a bit messy. So conf T. So let's just first up make all our ports trunking that we're using on these switches, so that we can get rid of this VLAN mismatch just popping up all over the shop. So interface range, FA fast Ethernet 0/1 to 5 actually on this top switch. Switch port mode is going to be trunk, and the switch port trunk native VLAN was 44 on this network. So we'll do that for switch 1. So we need to clear up everything. Probably not a bad thing to just wipe all your configs and restart, but sometimes in the real world very hard to do. So configure terminal on this switch there. Interface range FA0/1 to 4. Switch port mode is trunk, and switch port trunk is native on VLAN 44. And we're going to do the same over on the switch. So conf T, interface range, fast Ethernet 0/1 to 4. Switch port mode is trunk, and switch port trunk native VLAN 44. Okay, so they should all be tidied up a bit, and spanning tree will still do its gig. So there should still be paths running through. This side looks a bit iffy, but that's just a matter of time before that comes up. And sometimes Packet Tracer does take a bit of time. But this is still the root bridge of the top. So spanning tree is still running in the background. Okay, so let's go back down here and get our ether channel working. So ports 1 and 2, and 1 and 2 there, we're going to make a particular channel group. So these are the commands we're really chasing. Now the interface range we're going to use is 0, 1 to 2, and we've already got them trunking. So let's go in and do our channel group. So this is, we're creating this channel group within this range of interfaces. And we give it a number. Now if we put a question mark there, we can see here that we have a range of 1 to 6 options per switch. So let's make this number 1, and then we'll look at it. And the mode gives us a couple of options. So in our mode, we can use PAGP. So these two here, we have auto and desirable, and it's pretty much the same as dynamic trunking protocol, where you've got auto and desirable. So if I want to enable PAGP unconditionally on these two ports, so channel group them together or ether channel them, then we'll go desirable. Now if I want this to negotiate with the other side, and if the other side is running PAGP desirable, then it would negotiate and become PAGP if I have selected auto, if that made any sense. Okay, so let's go desirable. Now you can put desirable at both ends. That's fine, but that's what it's done. It's manipulated that. We have our ether channel now running across these two ports. Now these two ports will be down a fair bit because the other side is not in a channel group. So let's go over there. So we'll exit that. So interface range, fast Ethernet 0, 1 to 2. And they are trunking already, so let's just keep going. So what am I doing? Got a channel group, don't I? Now you can't tab that because there's channel group or channel protocol. So channel group. Now this number at this end can be 1 to match the other end, but it doesn't have to be. They have no correlation between switches. So this could be channel group. Let's make it 6. Let's work backwards, just for the hell of it, just to show that it can work. And the mode. Now we can put auto here, or we can put desirable. That's up to you. I'll go with desirable just to force it, but you can choose both of those. Switch port mode trunk and switch port trunk native VLAN 44. So with our channel groups that we're playing with, we have created our channel groups. And I think what I've just done there is reinforced it on the two other ports. So port channel 1, I think we should be still getting a native VLAN mismatch. So let's have a look. So interface, let's have a look what we've got. We've got port channel, so it's not channel group now. So port channel. And which number do we want to play with? We want to play with number 1. And hit enter there. And in that, we do have our spanning tree and switch port commands. So the same as any interface. So switch port mode is trunk for our channel group. Now switch port trunk native VLAN 44. So it's the same as we would do for spanning tree on a single interface, but what we're doing is creating another interface out of multiples and then manipulating our VLAN traffic, spanning tree traffic, even port fast, any cost that you're modifying needs to be changed on the channel group. It should take the first connection out of the range and actually make that the standard, but sometimes it doesn't. So we've still got that happening. So oops, I need port channel 6. What have I done? No. Yeah. Interface port channel 6. Switch port mode trunk. Switch port trunk native VLAN 44 and unblocking. So good. We have created our PAGP. So let's show our running config. And there on this bottom switch is our interface, port channel 6, switch port trunk native VLAN 44 and switch port mode trunk, so that's the same as we've had in other places. We combined these two interfaces, so fast Ethernet 01 and 02. You'll notice that it's the same stuff as under there with trunking. Keep it there. But this is where we've actually created our channel group. So the channel group 6, the mode desirable, another channel group 6 mode desirable there. With PAGP you can have up to 8 ports in of the same type and speed in a channel group. And we've only got 2 ports there, so up to 8. Yeah, if you've got enough speed on your switch, you can have 8 gig coming out of a switch with PAGP running. So yeah, there it is. We've created channel group 6, the mode is desirable, which says that we're running PAGP. Let's have a look at a few other pieces. So show interfaces port channel. Show interfaces. It's Etherchannel, sorry. And Etherchannel. Etherchannel, sorry. And we'll just hit enter there. So if we show interfaces Etherchannel, we see our protocol in here is PAGP. The pseudo port channel is 6. The channel group is 6 up there. If we show interfaces trunk, then we can see we've got port channel 6 is doing all our work, all our trunking up there. So 1 and 2 have disappeared out of our interfaces trunk. Our port channel is doing everything. And if we show spanning tree, then we can see again port channel 6 or PO6 is running everything there. One thing to note, the cost. So previously the cost for a fast Ethernet port was 19. Now the cost, because we've combined these two links together, is 9 as far as spanning tree is concerned. So just be aware of that when you do your spanning tree. And the last show command to play with in this show Etherchannel. And group 6 state, so it says max ports 8, protocol PAGP, so another place to play with it. Good to go. So let's do the LACP option now. Okay, so that is that one done. Now we want ports 3 and 4, connecting to 3 and 4 down here, to actually be channel grouped as well. So let's go through that whole process. So interface range FA0/3 to 4. What we will do now is channel group. We created channel group 1 up there before, so this needs to be another number on this switch. So channel group 2, and the mode, remember, is where we find out whether we are going to use PAGP or port aggregation protocol, or LACP, which is link aggregation control protocol, I suppose. Now passive is similar to the auto in PAGP. Active is similar to what desirable does. So let's go active on this one, then exit that. So this time what we'll do is go onto our interface port channel 2 and we're going to make it a trunk port and put our native onto 44. So switch port mode is trunk, and switch port trunk native VLAN 44. And again, our whole network should collapse until we do the other end. Let's go onto our switch down here. Oops. So, configure terminal. Interface range, same ones we're doing at the other end, but yeah, they can change around and flick around, so just be very careful of which ones you're putting into the range. So in this case, FA0/3 to 4. Excuse me. We're making this a channel group. Now this one hasn't got any at the yet, any numbers at the yet, so we'll start with 1. Remember, this is 2 at the other end, so again, those numbers are only local. Mode, and we put active before, so this time let's put passive so that they can negotiate. So those should now be negotiating. Let's exit that and go onto our interface port channel 1, and switch port mode is going to be trunk, and switch port trunk native VLAN 44. Now again, I did kind of say it before, but maybe not too clearly. What should happen in this channel group is we did the range 3 to 4. So that interface 3, which was already in trunking mode and already set native to 44, should be what this port channel actually inherits. Sometimes it may not, but if it doesn't, we can always go on to the port channel and manipulate it and do stuff from there. Doesn't seem too happy there, does it? The link lights look a bit wrong. So show interfaces trunk, and there's no port channel up and running, so show ether channel group 1, protocols running LACP, so it's just taking its time to negotiate by the looks of it. So show interfaces trunk, still nothing coming up. Oh, I'm pretty sure we've done what's correct, so let's show run. So interface port channel 1 has our switch port trunk native and our mode trunk. Interfaces 3 and 4 oops, come back down, come back to this. 3 and 4, they're both passive. Switch port access VLAN 22, we need to clean that out. So let's hop onto that again. So const T. I just made them trunk, I didn't clean out the access, which is a bit of a problem. So interface range should be in there still. Actually, we should do the range 1 to 4. Although that probably won't make any difference because we didn't have it. So anyway, no switch port mode access, and no switch port access VLAN. What do we have? 33. So let's just show run again. So it's one of those things when you do play with these that you really need to clean everything out. I think we need to go back into that and make them trunking in. Let's do it for all those ports. Switch port mode trunk. So show run again, and that looks good. That looks better. So always come back and look around. That's why I said at the beginning, probably the best thing to do is actually to clean out all your ports, just so that they, when you start reconfiguring, it all works out well. Okay, so let's go on to the bottom two now. So this is ports 3 and 4 on this switch, and 1 and 2 on this switch. So let's go on to 3 and 4 over here, and we'll do the third type of spanning tree. So conft, not spanning tree, ether channel. So the interface range in here is 3 to 4, and our channel group, we had 6 here before, so let's go to 5 now, just to work things around. And the mode is just going to be on. You can see this one here, enable ether channel only. Now what this says is it's not going to negotiate, it's just going to go on, and that's the end of the world. So the other end down here, we just have to put them on as well. So on at both ends. Let's just do that, and then we'll come back and sort other stuff out. So conft, conft, interface range FA0/1 to 2 at this switch. Channel group 2, I think we had before, up there. Oh, I can't remember now. Let's just do show run, and we have a port channel 1 already, and looks like we've lost our channel group for this northern bit, so we'll have to come back and fix that. 3 and 4, oh no, there it is, sorry, miles away. So channel group 1. So channel group 2, mode on. Okay, so they're both on. So let's just fix up our ether channel. So conft interface is port channel 2. Switch port mode is going to be trunk, and switch port trunk native VLAN 44, and we'll do that the same at both ends. We can exit that one. So our interface port channel, not channel group, but port channel. In this case it was 5. Switch port mode trunk. Switch port trunk native VLAN 44, just to throw a whole bunch of wobblies in it. And it's unblocking, so that's good. And let's just check if it's all up and running. So let's show ether channel. So we have 2 ether channels. One is group 5 and one is group 6. Remember, group 6 is 1 and 2 at the top there. Protocol nothing, so it's just on. PAGP is running at the top there. So let's show ether channel down the bottom right switch there, and we've got 2 groups, 1 and 2. Group 2 in this case is the number on this switch, correlates to group 5 on this switch on the left, but again it's just on, it's not running a protocol, it's just turned on. The protocol that's running between the switch down the bottom right here, switch 2, and the top switch is LACP, Link Aggregation Control Protocol. So there you go, max port channels 16. Although from what I've read, only 8 can be active at any one time, and the other 8 are in standby mode. So somewhat similar to PAGP, unless ports die, then it's better. Okay, let's have a look at the top switch just to make sure we're doing everything. So show ether channel up there, and there we have it at group 1 and 2. Now my groupings are just stupid. If on this size network you'd have group 1 and group 1 connecting down this channel, then group 2 across the bottom, and 3 on the top, just to make your life easier. But anyway, I did it just to confuse myself, I think. So there's group 1, PAGP, group 2, LACP. So let's show interfaces trunk, and FA5 going up to our router is in trunking mode, so that's correct. And our 2 port channels are the groups, channel groups that are running down to our switches, so that's good. We don't need to see any other interfaces in this, so we know that we're right if we've got those correct. So let's have a look at these geezers down here for the same command. So show interfaces trunk, and just port channel 5 and 6 running up and across. Now what's being allowed, so any black hole VLANs, other stuff, pruned, all that sort of stuff needs to be added to the port channels if it's not acquired from the first interface that it's created with. So be a bit careful with that. Show interfaces trunk, and the same on the bottom right switch, which, given that the top 2 are correct, a pretty good chance that the bottom right switch is going to be correct as well. Okay, so let's have a look at we show IP interface brief. There's another command. There's our port channels on there, so it's another command we can chuck in. They're up and up, so good. Let us show nothing. Interfaces, port channel, show interfaces, Etherchannel. I keep getting that wrong, I don't know why. And we'll just hit enter there. So in there we've got our pseudo ports all the way down, so let's go back up here. So fast Ethernet 1 and 2 are created together. The protocol is nothing, it's what we've seen before because it's on. It's part of PO2, so we can see in there which links have been aggregated into this ether channel or port channel. And down here we see LACP down there. LACP DUs, so the devices send little hellos across them, so that's okay. And that's about it actually. We have completed the 3 different versions of Etherchannel. We have shown you why we need to do it, and now we have, in this case, 200 megabits per second uplink there, 200 meg down there, 200 meg down there. If we show spanning tree, we have seen that we've got our port channels running through. Remember, the cost has changed because we've link aggregated. An interesting exercise for you to do is to actually pull one of these links out and see what the cost does. So it should go back to 19. I think under older switches it stayed at 9 actually, which was incorrect. But the root bridges, so spanning tree, still working through these interfaces quite happily. Just that it's changed the connection and the cost inside there. So, all good. Done. Thank you very much for listening.